Welcome guys. You are watching DSA Logic, your one-step solution for data structures and algorithms. I am Sheetal Chandra Nayak, a senior software engineer at Walmart Global Tech. Today we are going to learn about linked list. Linked list is a very powerful data structure as well as it is a favorite of most of the interviewers. A linked list is a list of nodes. A linked list basically looks something like this, where the first element is also called the head element, and you can see the first element is pointing to the second element and the second element is pointing to the third element. Third element is again pointing to the fourth element, but the fourth element is not pointing to any other element. So we can say this is the last element. So what we understood is the first element is the head element and each element in the linked list points to another element except the last one. Let's try to understand what is a node. A node basically is a combination of data and reference. Altogether that is called a node. Something like this. So we can say a node has two compartments. One is the data, second is the reference. Reference to the next node. So we can say our linked list can look something like this. Now here we can have the data of the node 1. Here we can have the data of node 2. And similarly this reference can point to this node and this reference can point to this node. Let's try to understand why linked list was needed. Was array not sufficient enough? As we all know, array is a fixed size data structure. So if we need a dynamic data structure, that time array does not works well. Let's try to understand how. Let's create an array of 3 elements. So we are going to create it here. Now let's say we had some elements into it, 1, 2, 3. Now we have an array of 3 elements. Now let's try to understand if we have to add one more element to this array. As this array is full, it does not have any empty space, we cannot add another element. So what we will have to do is we'll have to create another array of 4 elements, where first we'll have to copy the first elements of the previous array and then add the new element. Let it be anything. So as you can see, so whenever we have to add something new to the array, that time we have to create another array, copy the elements first and then add the new elements. Now let's think we want to delete one element from the array. Let's say we have to delete the element 2. Now we cannot leave it like this. We'll have to shift these elements here. So now it will become 3, this will become 4, and this will become blank. So as you can see, there are some extra steps needed when we have to add a new element or delete an element. If we have to update some element, that is completely okay. Like let's say we wanted to just update the element 3 with 5. So that was pretty easy in array. But when we have to delete an element or insert an element, so that time array is not working well. To overcome this thing, the concept of linked list was introduced. Let's see if we have to do the same operations on a linked list, what will be different. Let's first take our linked list here. So here is our linked list. Now if we have to add another element to the linked list, what we have to do is we have to go to the last element and then create a new node, and this node will be pointing to the new node. That's it. So we just have to create a new element and point to that node. That's for an add operation. Now let's take a look at the delete operation. For a delete operation, we'll need the linked list again. So let's say we wanted to delete this node. To delete this node, what we actually have to do is we have to point this node to the next node. Now you can see the first node is pointing to the third node. Second node is also pointing to the third node. If we delete this pointer, then nobody is pointing to this node or this node is pointing to any other node. So this is an isolated node and the first node is pointing to the third node. By doing this, we have actually deleted this element in the linked list. In Java, garbage collector will clean it up. In other languages, you have to delete this node in a different way. That's the only change. But the main concept here is we just have to change the pointer which was pointing to the second node to point to the third node. Let's say if we have to add an element at some particular index into our linked list. To do that, we'll have to see our linked list again. And now let's say we want to add an element before this element. To do that, we'll need to create a new node. So this is our new node. This is being pointed by the first node, and we just need to update this pointer which is being pointed from the first node to this node. We need to change this pointer from here to here, and that's it. So it is easy, right? Compared to arrays where we have to shift all the elements to the right side, make a space, and then add the new element. There are some pros and cons of both in arrays and linked list. We learn more about it while we code. Java collections framework already has a linked list. In our day-to-day coding, we can use that linked list. But for an interview purpose, we need to know how to create our own linked list. So let's start. To create our own linked list, what we need is basically the head node. So let's create a variable private node head. Now this node is not defined yet. Let's define this node. We can create a static inner class, static class node. Now this node will contain two things. One is the data and one is the pointer to the next node. The data can be of any type, whatever we want to store in our linked list. So for now, let's create a linked list of integers. So int data and node next. That's it. We will need a constructor and we are good to go with our linked list. So let's generate our constructor, and we just need data in it. So we have created our own linked list. Yes, only this much is needed to create your own linked list. Now let's try to test this out. Let's test it out. To test it out, what we need is a main method, main, and we'll have to create an instance of our linked list. So we can do something like my linked list equal to new my linked list. Now we need to initialize the head value. So list dot head equal to new node. Let's put data as 1. So now we basically have the head value initialized with the node whose data is 1, but the next value is null because we didn't initialize it, so it will be null. And we can say we have a linked list of only one element. To add more elements to it, we need to point this node's next to the newly created nodes. So let's add some more elements to it. So let's say the data will be 2, and we need to point head elements next value to the newly created node. And similarly, we can go ahead. Let's change the data to 3, and this will be list.head.next.next. We can simplify this by creating an add method. We don't have to do it like this further, but for now we need to understand this part properly. List.head.next is pointing to the node which is having data 2. So this is basically the node 2, and this is the next value which is pointing to the newly created node 3, and node 3 is not pointing to anywhere else. Now we have our linked list. Let's test it out. So to test it out, we need to print it. So let's do s out, and we'll try to print list as it is. We are getting something like this. This is the string representation of the memory address where the linked list is created. But we want to see the actual data. To do that, we need a toString method. Let's create a toString method. So we can override the toString method, and this toString method, we need to create a string which will look like our linked list. To do that, what we need to do is iterate through the linked list and create a string representation for it. To do that, what we'll do is create a string builder sp equal to new string builder, where we'll append our data and the representation. Now at the end, we'll return this sp.toString. Now here we have to iterate through the linked list and add all the data to the string builder. To do that, what we'll need is a for loop. So this is a for loop which we use basically for iterating any array or something. But here we have to iterate a linked list. So to do that, what we need is, rather than int, what we'll do is change it to node. This I, we can say it as a temp, and this 0 can be the head. So we are basically initializing our for loop with a temp variable where temp is equal to the head, and in the place of I++, what we need to do is temp equal to temp dot next. Now in the place of condition, so we need to iterate our linked list till we get the final value, which in our case which is 3. So we can say till temp is not null, we can go ahead. So we can change the condition to temp not equal to null. And now we just have to append the value of the temp node to our string builder. So sp dot append temp dot data, and to look good we can append an arrow so that it looks like a linked list, and we are good. Now let's try to print it again. So here you can see our linked list is getting printed properly. So 1 is the first node, which is pointing to the second node, which is having the data 2, which is pointing to the third node, which is having the data 3. And the third node is not pointing to anywhere because it is the last node. This toString method uses a linear approach. So for the problems which needs a linear approach like linear search, or if you have to find a max value or min value, for these kind of things you can reuse this for loop. Only thing which you'll need to change is this particular logic. So if it is a linear search, you need to change it with the if condition to check if the data is equal to the search element or not. If it is a find a max or find min, you just have to change this particular part. For those who don't know about linear search or linear approach, they can click on the I button and check out my video for the linear search, where I have explained the linear search and linear approach using arrays. You can use the same concepts in the linked list also, so do check out. And we will be doing a lot many operations on the linked list, but in the next video. Hope you liked it. If you liked it, please like, share and subscribe. Thank you so much.